Good evening, friends. It is my privilege and honor to give you and extend a warm. Good evening, friends. It's my privilege and honor to extend a warm welcome to all the panelists as well as the audience for our 8th technical session of 2021. The topic today is development of autonomous underwater vehicle, and it is going to be presented by Dr. V.B.S. Ayyangar from NSTL, Vizag. We are privileged to have Dr. Purnima Jalihal from NIOT. She is a very, very well-known person in the industry and in the academia both, and also is one of the well-known scientists in India. And the session is going to be chaired by Dr. R. Vijayakumar from IIT Madras. With this welcome, I transfer the reins to my colleague from INA, Commander Kaple, to introduce Dr. Vijayakumar and take the program forward. Thank you very much.
Thank you, Mr. Dasgupta. Good evening, everybody. Commander Manohar Kaple here. On behalf of our Institution of Naval Architects, once again, I welcome you all. It is my privilege, and it is my pleasure to introduce Commander and Dr. R. Vijayakumar, who is also my Navy colleague from Department of Ocean Engineering at IIT Madras. So Dr. Vijayakumar has been there with IIT Madras since February 2016, and before that for 21 years he was with Indian Navy. And the amount of study which he has done is phenomenal. He did his naval architecture from Cochin University, QCET. He did his postgraduate diploma from IIT Delhi. Then he did MTech in Ocean Engineering from IIT Chennai. And thereafter, he has completed his PhD from IIT Delhi. And after that, since the time he joined IIT Chennai as a faculty, he has guided 5 PhD projects, 3 MS projects, and 24 MTech projects, and published more than 25 papers in international journals and 50 international conferences. So that's really phenomenal. Sometime back, he had given a presentation in this forum about the practical research or model testing, which is being done at IIT Chennai. So the hydrodynamic model testing, and he is one of those rare calibers available who have the practical experience of hydrodynamic model testing as well as aerodynamic model testing, because his PhD topic was aerodynamics and fluid mechanics at IIT Delhi. In Navy, he is considered to be a highly decorated officer with 3 commendations in his name. And he has done all kind of possible appointments in Navy, in design directorate, in production, in inspection, and with this kind of a practical experience, when one goes to the field of academics, then the value which he brings is immense. So with I'm very proud of my colleague, and I would now request Vijay to please take over this session. Probably he is the most competent person to chair this session. Vijay, please.
Yeah. Am I audible, sir?
Yes, you are audible.
Thank you very much, sir, for the very nice introductions, and it is my privilege to chair the session. And as a part of my duty, I have to introduce 2 stalwarts, Dr. Purnima Jalihal as a chief guest, and Dr. Bhardwaj as a speaker. And I have been given a written biodata. Before that, I would like to speak few things before going into the written biodata. I have known them both. In fact, when I was doing my MTech here, I had gone and met Dr. Purnima Jalihal. That time it was, I think, around 2002 to 2004. The wonderful work which have been done by NIOT was quite eye-opener. The amount of work they do in the oceans, ocean renewable energies, and of course, their field is quite vast open. And with this, and with respect to Dr. Bhardwaj, I've been knowing him since his BTech days, and I've been seeing him how he has been shaping up into a scientist and his work and taking up a project in NSTL. I will get on to the written biodata. It is my privilege to introduce the chief guest, Dr. Purnima Jalihal. She is a senior scientist who heads the Energy and the Freshwater Group in NIOT India. She has coordinated many projects. In fact, to put it, it is first ever projects in ocean energy and desalination. She has a tremendous contribution in setting up the first ever ocean thermal gradient-based desalination plant at Kavaratti Island in the Lakshadweep group of islands in the Arabian Sea, and which has helped them to transform the lives of the small island community which had a serious lack of drinking water. Very relevant, socio-relevant work. For this work, she has been awarded the Vishwakarma Medal in 2006 by the Indian National Science Academy. This success led to more plants in islands and also scaled up a demonstration offshore. She has also led device development for harnessing ocean energy from waves, marine currents, ocean thermal gradient, that is WOTEC. The wave energy powered navigational buoy for the use in ports has been demonstrated successfully and has now been transferred to the industry. The marine hydrokinetic turbine was successfully demonstrated in Andaman, and the first ever wave energy powered desalination system was also demonstrated in Villingam, Kerala. Currently, she is focusing on scaling up and is also leading the first ever WOTEC powered desalination plant in Lakshadweep. She has a PhD in civil engineering from Duke University, USA. She is also on many committees of the Indian government organizations related to water and renewable energy. She has also been a chairperson of the Indian Desalination Association South Zone. She was awarded the Yuhara Prize for the year 2019 by the International WOTEC Community for contribution to the development of ocean thermal energy conversion. She is the EU-led Clean Energy Mission Innovation Champion for the India 2020. She is also currently the Vice Chair for the Executive Committee of Ocean Engineering System (OES) Technology Collaboration Platform (TCP) under the International Agency IEA. She has also accepted our invitation to deliver a lecture about NIOT in the later sessions. And now it is my duty to introduce the speaker. Dr. Bhardwaj Srinivasan is currently a scientist in National Technology Laboratory, NSTL, Visakhapatnam. He is graduated from Cochin University as a naval architect and has done and as in doctorate. In fact, MS as well as doctorate, he has done it in IIT Madras in the field of naval hydrodynamics. He has about 20 years of experience as a professional with 16 years as a scientist in the field of naval hydrodynamics. His professional expertise is also in the area of ship design and autonomous underwater vehicle, which he is going to speak today. He was awarded the Young Scientist Award of DRDO in 2008. He is also an AV quizzer since his school days, and he has won the National International University Quiz during the college days and was a participant in the Mastermind India Quiz of the BBC. He is also conducts quiz programs for school children, particularly the book-based quizzes organized by Ahmadiyya. Okay. With this, I would like to request the chief guest, Dr. Purnima Jalihal, to give us a few words.
Good afternoon, everybody. First of all, thank you very much for giving me this opportunity. I must thank Mr. Das Gupta for this, connecting back with me after so many years and giving me this opportunity. And also thanks to Dr. Vijayakumar for introducing me. So I'll just share the screen and I'll then begin.
The screen is visible, ma'am.
Yeah. So thank you once again, and I'll just give a very brief sort of talk. I thought, like I said before, it's better to give a PowerPoint presentation because then you can see some of the activities that we are concerned with. I'm also very happy to be able to participate in this organization's webinar. Normally, with all the travel and all, we would never get an opportunity to be part of so many different varied organizations and their workshops and webinars. So I'm really happy to be part of this. What I thought is today I'll talk about something related to the blue economy framework, because this is an important thing right now, an important aspect, and even the Indian government is looking at it with very, very special emphasis. Specifically to blue economy, I'll just talk about energy and underwater technologies because that is relevant to the talk of the day. And Dr. Ayyangar has been interacting with NIOT, and he will have a lot to say about this, but I'll just touch upon very briefly on how it falls under the blue economy framework. So essentially, just a short background of why we are talking about all these things today. All of you know, I mean, this is a naval architectures group. So all of you know that oceans cover 72% of the earth, and it also supports food, resources, livelihoods, tourism, and trade. I mean, these are all have been known to us sort of in some way or the other since, since forever sort of. However, this is the time when people have realized and are putting everything together and trying to do some things more, than what has already been thought of or done so far. The oceans shape our weather and climate. Basically, they are the life on Earth, and the relationship is ever changing with the way the climate change. And there is a whole big 1 or 2 hours talk that we can talk about only the climate change and the ocean. However, the main thing right now, the UN realized, and this decade is called the UN Decade for Ocean Science for Sustainable Development, and the most famous one is the SDG 14, where it is, the life below water is addressed in the SDG 14. So the important things for the sea is not only the resources and livelihoods, the freedom of the seas, as far as the country and the political arena is concerned. The security and the freedom around in the seas around us is very, very important. And of course, there are a lot of growing influences, but then this is a cause of a threat for the future security, and therefore all these things have to be looked at in totality to see which technologies need to be developed. Everyone knows the Indian scenario. I deliberately showed this slide just to, again, sort of, impress upon everybody about the large EEZ that we have, the long coastline that we have, this bunch of islands in the Bay of Bengal and the Arabian Sea that we have, which also adds to the EEZ, and which is why we need to take the oceans more seriously than we have been doing so far. So just to tell you, the Indian government right now is facing or is like taking up many, many challenges and is working really on mission mode for various aspects. I mean, all of you would have heard of the recent hydrogen mission. We're trying to get into artificial intelligence. So similarly, there is a strategy being worked out for blue economy. It has been given a big emphasis for the last couple of years. Actually, the empowered committee of secretaries had several 8 or 9 kind of areas that they were working on. Blue economy was decided as one important goal, and Ministry of Earth Sciences actually is going to spearhead this. Right now, a draft of the blue economy strategy for India has been circulated, and it was kind of seen by several ministries and several, researchers, academia, lots of people. The final draft has now been made available, and at some point it is going to be launched, and MOES will be sort of the nodal agency for that. So I would like to read this one out because this encompasses everything that we need to know about what we need to do and why we need to do it. So the Indian blue economy, see, world over blue economy is being talked about, but what does it mean for India? And that is really important. So India's blue economy can be defined as a subset of the national economy, just for the reasons I told you about how large the ocean is around us. It is, for India, it will comprise of the entire system of ocean resources as well as the man-made economic infrastructure. In fact, I've just recently written an article on why ocean technology is important for India, because we are lagging so far behind that today naval architects and offshore engineers have to rise to the occasion and try to make things, really better for the future for India. There is a legal aspect associated with the oceans, and that has to be taken care of. Environmental sustainability, national security. So you see, this has got all these, it may sound like buzzwords, but they are all very, very important in the entire context of blue economy, and therefore they have to be all dealt with separately. And therefore, the 7 priority areas which were identified under the blue economy draft, that has been prepared, that is, these will fall under the framework. So one is the National Accounting Framework for the governance itself. Coastal marine spatial planning, this is very important. I think now there is probably a sort of a mission kind of thing going to take up this work also. That encompasses things like tourism. The project area 3 is really important for India because it has a huge economic potential, and that is marine fisheries, aquaculture, and fish processing. There are like manufacturing, industries, trade and technology, and skill development. That is one aspect, which is, you can see by these 7 areas that each one is absolutely independent of the other in a sense of the content, but they're all loosely connected through the oceans and because they depend on each other. So it's very, very, the blue economy concept and the areas that have been identified now in the Indian context are really, really very important. Logistics, infrastructure, and shipping. Of course, all of you in this group probably already are aware of the Sagarmala, whatever they are doing and what they are kind of supporting. And this falls largely under that kind of a regime. Now, priority area 6 is what I will talk a little bit about a few minutes after this: coastal and deep sea mining and offshore energy. Now, these are still in the technology development and R&D mode, but they need to be taken forward because they have huge commercial implications in the future. And lastly, of course, as I said, security, strategic dimensions, and international engagement. And underwater technologies is like, it also falls in this ambit for security reasons. And it's also, the mining part of it, which is tackled in area 6, the technologies developed kind of fit in there also. So that is why in that sense, this talk is really important today. It has got a lot of ramifications, and especially in the blue economy context, it can play a very large role. So talking about what NIOT has been doing right now, of course, I'm going to just speak for a couple of minutes on this because there is a whole lot of things that need to be discussed when you talk about a device development. But we have largely been working on wave energy, current energy, or rather like, hydrokinetic turbines, which work with tidal streams, not tidal range, because India has very low tidal range. We have only in the Gulf of Khambat and Sundarban, so we can't really, tidal range turbines are not really very, very useful for India. And OTEC, that is using the ocean thermal energy. And let me tell you that this is being seen as very, very important today. The Biden administration now has really started looking at climate change and clean energies. Very, very suddenly there is a big spurt and an impetus has come. For a long time, there had been a lull in the US activities as far as OTEC went. But I would like to say very emphatically in this group, because I'm sure there are a lot of people who are innovators and who would like to do technologies just specific to India and are indigenous. When we did thermal desalination, which I'll come to in the next slide, we did not say that this is not being done in the US or this is not being done in Europe. We did it because we wanted to do it, and it had relevance to India. So that is why we have not stopped working on OTEC. And the beauty is, last month I was actually approached by the US Department of Energy and was asked to give a talk because they are looking at India now to learn from. Okay, so, and their interest in India and the OTEC and thermal desalination activities has grown so much that they think India can be a partner for this, and then they see a future. US will always do things where it profits them, and obviously they see a profit in this. So OTEC has taken up suddenly again, and it is becoming really important and will be important in the near future. Now, we did had some experiments which we tried to do for OTEC, and Mr. Das Gupta is aware of that. We had actually even built a barge for that, and we could not complete the experiment due to lack of proper marine infrastructure. And as I said, I have been saying for the last several years now that we keep talking about the lack of marine infrastructure in the country, but we are still way behind, and we really need to do something about it. And without that, it's a catch-22 situation. We don't have it, so we can't do big things. We can't do big things, so we are not able to, come back and say we have developed in a certain area. So there is a lot to be done. When we did the Kavaratti project for the first time, it was done with, frankly, with total lack of knowledge. We learned on the job, and believe me, for 16 years, this plant has been successful. We are very proud of it. It has not had any environmental impact for the last 16 years. Every single thing is made in India. I myself have gone in the boat and deployed that pipeline. So, it gives a lot of sense of satisfaction that it has helped the community. Subsequently, we also made plants in Agatti and Minikoi. We scaled up, and Mr. Das Gupta will recognize that barge. We also showed 1 million liters per day back on that same barge, which was originally made for OTEC. And then we have also done, why I'm showing you this is because under the blue economy, water has been given a priority role, because the entire 30% of the population which lives on the coast of India is, lot of areas are water stressed. And any new technology, any new environmentally friendly technology is very welcome. It, of course, water also has a huge commercial implication and can be a source of, like a source of earning. We've also done the same technology we have demonstrated in power plants. Again, we're talking about environmentally safe technologies, and this technology, when demonstrated in the power plant, actually can help mitigate thermal pollution, because all coastal power plants are discharging very hot water in the seas. So having said about ocean energy and water, the last thing on that is that we have taken up the new challenge now. We have been, all the desalination plants in the islands, because they're so far away from the mainland, they depend on the diesel generator grid. And we have been using diesel generators to power the plants. Now, for the first time, we are going back to OTEC now. This will be an OTEC powered desalination. That means the plant will not depend on the diesel generators for the power requirements at all. It will be totally self-sufficient. This will be the first time in the world anybody has done it. And there are a lot of challenges here. There's a turbine which nobody has made before, and there is a 4-kilometer long pipeline this time. So we have started the work. We are just about to place some orders on some of the basic main aspects of the project. And hopefully in 2 years' time, we will have a successful project. As far as, again, blue economy and the coastal, and also the number 3 part there with the marine, biological aspects is concerned, we have been making biofuel from marine microalgae. And like I said, there is a lot of scope in all these kind of mission mode areas where you can do inter-institutional and multi-institutional kind of endeavors. And in fact, just recently, I asked CSM CRI Bhavnagar to work with us. We have just submitted a joint proposal where biodiesel can be harnessed from seaweeds and from marine microalgae. This also has, of course, it's not only clean and green fuel that can be used in. We have actually demonstrated in the Tata Sumo using this diesel, and NIOT has demonstrated this using the lipid extracted from something. I'm not a biologist. It's called Chlorella vulgaris. The other thing that is part of blue economy is food and sea cage culture. See, in NIOT, we are not into the actual biology, but we are into developing technologies for harnessing, biological animals and things. Can I take another couple of minutes only?
Yes, madam.
Yeah. So I hope I'm not. Yeah. So just
It's
a
fine,
couple
madam.
of minutes, okay. So these are cages where the fish are being grown and harvested. We have transferred the technology to self-help groups so that they can be a income generation there. Right now, the one that we are working on is to make these cages in such a way that they can be autonomous. So if there is a heavy climate or a heavy cyclone or something like that, they should be able to go down, come back up when the cyclone recedes, so that it will be a one-time investment and easy for the coastal community to look after. So that is as far as food goes. These are like just pictures of how huge amount of fish can be harvested from these cages. So now I come to the underwater technologies. Of course, today Dr. Ayyangar will speak at length on that. But what NIOT has done is there is an ROV that we have, which is qualified for over 5,000 meters. It has gone several times to that depth, taken a lot of pictures. And these are some of the, if you look at the bottom left picture, I personally, I didn't even know that such organisms exist at that depth, 6 kilometers below. We don't know what is there. I mean, it's so fascinating. It's so interesting to see what goes on there. So we've taken a lot of pictures, and there is a huge amount of information and data now collected. It has gone several times. And we have also helped NSTL, like he said earlier. There's a little ROV that is made. It's called the Polar ROV. It has been taken to polar waters also. And then this is something that is small and can be handled. And there is now a lot of people have asked for this, and this could be really useful in future. It has taken pictures of the polar areas. It has gone to, it can do coral biodiversity pictures because it is so small. It can go in and around corals. So, for islands, it's basically quite it's a small spin-off kind of thing after the experience of the larger ROV, Deep water autonomous underwater vehicle. This is not made here. We have bought this actually. It is just about to come. We have placed order, and some of it's on the way sort of. It will be there in a few months. But we hope to learn using this and then probably indigenize it sometime. So this is something that we have bought from Kongsberg, Norway. This is the AUV. And this is one of the flagship programs going on for quite some time, the mining mission, the mining project. Right now, the latest success last month was that it actually went down to 5,000 meter depth and it crawled. I mean, it has actually, locomotion trials have been successful. We now need to do the crushing and collector tests, and those also are shortly happening. These are those locomotion tests that I talked to you about. For finding out what sort of soil it is down there, an in situ soil tester was developed. See, all these have to have the challenge of the depth, and have to be designed for the depth. So all these are have like serious challenges in their design. This is another very complex thing, the autonomous coring system for detecting where gas hydrates are and for ground truthing. So this had problems and could not be operated for a long time because, the footprint when it goes into soft soil was difficult to get a core. But we have had success now. It was able to be launched, and then we have even drawn a core and brought it back, especially in the KG basin. As you all know, this is required, in that area where gas hydrates are prominent. Lastly, the manned submersible. This is our flagship program today. We will be sending 3 men down to 6,000 meters. It will have a 12-hour endurance, and it will be rated for 6,000 meters. It's called Samudrayan. This is currently right now for the government, the OTEC powered desalination, which I talked about earlier, and the manned submersible. These have been identified as the flagship programs. OTEC powered desalination is being monitored continuously by NITI Aayog. And this, of course, it comes under the deep ocean mission, which I'll just show in a minute. Again, we need to work on gas hydrates. Work has come to a little bit of a halt right now, but we have been doing some work in the past. So I'll conclude with the last couple of slides to tell you what the Indian government initiatives are for furthering some of these technologies. So for ocean energy and desalination, actually MNRE has now notified that ocean energy also can be considered as a renewable. That means whatever concessions solar and wind have been getting, Ocean Energy also can avail of those concessions. So that is a very, very important development. The other thing is there has been a lot of effort to start a desalination mission or an entire mission mode desalination activities. Several meetings were held. I have attended meetings with the minister and lots of things. Finally, it was given to DST. Right now, to further work on desalination, we have launched a call only for proposals for desalination for various levels, basic R&D, technology demonstration and prototypes at different funding levels. And this is, we are hoping to bring a lot of academia and industry forward so we can identify good technologies and start putting them up wherever they're required. International efforts, I have managed to somehow with a lot of effort make India a member country for the Ocean Energy Systems Technology Collaboration Program under the IEA, that is the International Energy Agency. And India led a group in a subtask for making a white paper on OTEC. This is just ready now and it is going to be published shortly. I'll share it with anyone who's interested once it is ready. And my last slide, and this is really important even for this forum. The cabinet approved the deep ocean mission. The amount for this mission has been identified as around 4,070 crores. So there's a huge amount of money. There are 6 major themes in this. Development of technologies for deep sea mining, all underwater technologies actually, and NSTL and NPL are going to be partners and will work jointly with NIOT on many aspects for these. Development of ocean climate change advisory services, which will be spearheaded by ICOIS. Conservation and exploration for biodiversity. This will be basically by CMLRE, but with a huge content for NIOT. Deep ocean survey and exploration will be spearheaded by NCPR. Energy and fresh water, which I'm leading. And actually, I should tell Mr. Dasgupta that the 10 MLT project, which he started first, we got a wonderful DPR from L&T Valdel, even though he was not associated with it. And at some point, Niti Aayog wanted that to be part of the deep ocean mission, but is really high on capital. So what they did is let us make it phase-wise. So right now, 100 crores has been given under this, just because the cold water conduit is one of the biggest challenges there. So we will be scaling down the conduit, but testing it in deep waters in 1,000-meter water depth off Chennai. And so 100 crores has been given. If it works, then it may be in the next phase, because that will be India's first semi-submersible if and when built. And that's why we are really, still keen on making that happen. And the last one is an advanced marine station for ocean biology, basically a research kind of area where we can take academicians and work with universities. So I hope I have not exceeded the time too much, but thank you very, very much for this opportunity.
Thank you, madam. And there are certain questions and certain comments.
I'll stop sharing the screen.
Yeah, yes, ma'am. So we will have it after the speaker.
Sure.
May I now request Dr. Bhardwaj to continue with this.
Oh, thank you, sir. Just share my screen. I hope I am audible.
Yes, sir, we can hear you.
I thank our chief guest, Dr. Jalihal, for giving a nice developments of NIOT, which is complementary to what I'm going to present on the development of autonomous underwater vehicles and the purpose which she has beautifully told. So I'll directly go into the autonomous underwater vehicles itself. We've been talking about tethered systems.
So we are not able to see your screen yet. Yeah.
Even your video is.
Are you able to see my screen now?
No. till the time the screen is coming online,
Yeah.
there are some questions which have been asked to Dr. Purnima. Madam, will you be able to answer?
Should I answer them now?
Till the time he gets
Till he shares? Okay. So there's somebody who's asking, there's somebody who's asking who funds the ROV. Is exploration done in by Ambani? So I'll just tell you that the ROV that I showed is funded by the Ministry of Earth Sciences, and exploration is being done. And actually, even we are trying to collaborate with ONGC also. Exploration is being done by several people. This particular thing is for development. We are not like actually going around doing the exploration. That is not our mandate. We do only the technology development. Okay. Then the next thing is ROV for the ocean floor. How far the marine? Actually, the marine floor, I must say, because even the 500-meter water depth or 400-meter water depth, where we are drawing the cold water from for our desalination projects, it's pristine and very, very clear and very good quality water. So fortunately, I think in 6,000-meter water depth, as yet we have not been man has still not been succeeded in spoiling that as yet. So that is why I stressed on environmentally friendly all through my talk. Whatever we do should be environmentally friendly, and we are doing that. I think he's trying to share this. Okay, later. Thank you.
Ma'am, perhaps I'll just wait till your answer is over, ma'am.
Fine.
Okay.
I'm done with the questions, I think.
Can I start now?
Yes, Bhardwaj.
Thanks, ma'am. Your presentation has set a stage, which I hope I'll be able to follow. So when it comes to autonomous underwater vehicle, I'll directly jump into the autonomous underwater vehicle. Ma'am has presented on the tethered systems, ROVs, which are being used, which I would call as tethered propulsion systems, or the towed systems. In both these cases, we have the cables which are going to run till deep water, which is a significant design cost, both in terms of its drag. So the idea came that we can have the same set of sensors with unmanned systems. So to put a definition to autonomous underwater vehicles, it will have its own power. It is untethered, so it should have its own propulsion controls, and it has software which defines its task, and it will perform the task according to the software, and it will have its own autonomy. With this definition, we can go to the types of AAV. The AAVs have been here for 60 years, but still we cannot standardize until this is the shape or size of the AAVs. They are of various sizes. Academic research in the Indian context, we should thank NIOT, because NIOT was holding a lot of annual competitions to academic institutes. A lot of AV ideas came, and the small size AV of less than 1 meter and man-portable AVs were all developed by a large number of institutes in India. And the other is the civilian and military. That is the way of looking in terms of application and use. And in terms of geometry, when we look, either it can be a torpedo shaped, where we have a long cylinder with hydrodynamic shaping in the forward and the aft. That's the most popular shape of AVs. For various other reasons, you can have a non-torpedo, what we call as flatfish, which is more like a box-shaped AV. And when it comes to sizes, as I told, it can be a small, medium, or large. The small AVs are typically man-portable. Just drop it in water, then it does its mission and comes back. The medium AVs are mostly civilian or military. Ma'am showed one of the medium AVs, which are basically between maybe say 500 to around 1,500 kgs. And they launched from the vessel, and they have got a little bit more of endurance, and they carry a bit more payloads. And the larger ones, which have long endurance, better payloads, and better navigational abilities. When it's coming to the shape, I personally worked on flatfish AVs for quite some time, and also I studied the torpedoes shaped AVs axisymmetric. One of the significant differences in terms of the vehicle configuration is that when we design an axisymmetric vehicle, we would find that when we distribute various systems, these AVs will typically be having a watertight compartment to house all the systems, which I'll be discussing the systems in the future slides, and a freely flooded portion. And this freely flooded portion will be very limited in the case of axisymmetric AVs as a percentage of total volume, while in the flatfish configuration, they can be almost half-half if we plan the configuration properly. This offers a lot more flexibility for the operator level person also to put various payloads, while in the axisymmetric configuration, you can only put a defined set of payloads. That's why I call this as a mission specific, while flatfish can accommodate various payloads. And propulsion is generally twin screw with whatever advantages and disadvantages that twin screw has in the flatfish configuration. When it comes to the technologies, again, I would group the technologies into vehicle technologies for the AV. And there are some technologies which are to be in the mothership, particularly launch and recovery, as well as mission control station. I put the technologies into three groups. One is the basic technologies, which given an AV design and given a vehicle configuration, this could be the basic defining platform technologies. And then we have the operational technologies, even within the same platform or the same design. Depending on the operation, you will tune these and put or not put some of these things. Then we have got the payloads, which depending on the mission, you put a specific sense of payloads. So in the basic technologies, we have the hydrodynamics. Here, the hydrodynamics includes the vehicle shape, size. I'll go a bit more detail in this forum, as well as the propeller and the rudders and stern planes, which are going to be used for the control of the vehicle. Propulsion is the prime mover, mostly electric motor, and it has to fit into the form of the AV. The controls, which where you develop the controller for the stable performance of the AV. Navigation and guidance, which includes a set of navigation sensors as well as path planning. Actuation, again, the set of motors which with its own feedback circuits, which takes the command from the mission computer and undertakes the movement of the control surfaces and the propulsion in case the speed control is there. The hull structure, which is made out of, which defines the watertight and the non-watertight boundaries and the physical boundaries of the vehicle. The power source with all these electric vehicles which are coming, most of the power sources are batteries. Fuel cells are also undergoing research. And these battery chemistries are going to define the vehicle size and the application. The electrical system is the power distributor with its own logic with respect to fault tolerance, and the computers which hold the entire software. And since it is autonomous, it also has to have a set of health sensors to monitor its own health. And in case there is a problem with some of the systems, then the appropriate actions will be taken by the computers. Under operational technologies, I'll call the mission plan, which is in two halves. One half, which is already in the guidance algorithm in the vehicle. The outer half is the planning of the mission itself, which will be loaded into the AV before the mission, which could be a time optimized or an energy optimized path, depending on what mission we want to do in terms of volumetric coverage or the area coverage. So these are all defined in the mission plan. Then obstacle avoidance, there are areas where obstacle avoidance may not be required, and there are cluttered areas where obstacle avoidance is required. That is the reason why I put it in the operational technologies. And communication, there are various options, but the primary option in underwater is acoustic. When it comes to surface, we have all the options in UHF, VHF, SATCOM. So what the user wants or the owner wants or the operator wants can be decided in the communication. And then we have the recovery systems. These are systems in the vehicle which act when either a fault is detected and something has to be done in terms of emergency beacon locator or similar systems. And the other recovery aids are when the vehicle surfaces, it sends a signal to the mothership so that the locations are known and it can be picked up. Then we have the payload, primarily, which are basically sensors which collect the information in the area or in the volume of the ocean. Complementary to this, the perception technologies, where when a large amount of data is collected and we are looking for specific things, it gets coupled with the perception technologies, in terms of image classification, image identification, so that we identify certain geographical features or other features which we are interested. Then in the mothership, we have the launch and recovery, particularly for heavier vehicles. It's become very important to design a right way of launching and recovering the vehicle. And the mission control stations, which will be having the mission planner, as well as in case we are able to have some communications like USBL tracking, mission tracking, as well as post-recovery mission analysis. So this more or less covers the technology part of the AUVs. Now, when it comes to the development process, here my focus is on the hydrodynamic design, where from the vehicle mission requirements, there are three things which evolve. One is the vehicle shape and size, which is also governed in a sense by the power systems or the batteries that we choose. Because when we have a certain endurance, we have a certain volume. And then when we want to increase the endurance, then the size has to be played around with. So it's a play between the endurance and the efficiency of the battery systems and how much charge-discharge ratio that we have. That is why that is one of the factors for the vehicle shape and size. And the navigation, which is basically deciding how accurately you want the localization to be done and how deep you want to operate and how frequently you have to surface. I'll cover it slightly in more detail slightly later. But my main block is basically the vehicle shape and size, where we characterize the hydrodynamics in terms of the hydrodynamic coefficients, drag, propeller efficiency, propeller coefficients, which we put in the mathematical model and undertake the trajectory simulation for a required trajectory, which can be used for stability analysis. And the hydrodynamic characterizations, once we characterize the vehicle in terms of its hydrodynamic coefficients and numbers, we can also use them for stability analysis. Generally, AUVs operate at different mediums, and so there should be a way of controlling the buoyancy, CG and CB, which will be done in the freely flooded portion, which indirectly also means that there will be a band where I have to set my CG, CB, and buoyancy. So how much can I vary my CG, CG, and what is the band of CG, CB, and buoyancy is also studied by parametric variations. And then in case there are any redesign which is required, then we design the control elements, rudders, turn planes, passive planes, etc. to achieve the required trajectory performance. This is fed into the control law, where we design the control and guidance algorithms. And here, when it comes to the other vehicle hardware systems, as a part of the mechanical design, we have the pressure hull, we can have the exostructure, and in the pressure hull, there will be a freely flooded portion in the watertight compartments, and taking the entire hydrostatic pressure in accordance with the depth of operation. And this defines the physical boundary, the batteries, and the navigation, sensors, onboard electronics, and computer systems. The third block is generally not very critical in terms of the volume coverage, because even for different sizes, we can almost have the same volume of the systems. So the batteries will be the primary volume, will be primarily deciding the volumes. And with all these things designed, we can do a prototype development and the vehicle trials to again check back in the mission. This is the framework which I follow for the vehicle development process for an AV, with an emphasis on the hydrodynamic design. The reason being that when we have the whole design cycle, it's about what we can change at a later stage and what we cannot change. And when it comes to navigation, onboard electronics, and computer systems, as I've told, they occupy lesser volume. And by the nature of development itself and the nature of obsolescence, they keep changing very frequently. On the other hand, a given hydrodynamic shape, it is going to be very costly change in case we don't get it right. That is the reason the hydrodynamics or hydrodynamic design gets a little bit more emphasis, particularly when we are defining the configuration of the vehicle. By hydrodynamics, I mean the design requirement is to have a stable, maneuverable, and controllable vehicle for a given basic shape, size, and vehicle configuration. This is governed by the endurance and the operational requirements. And we expect the design outputs to be the weight distribution. When I tell the weight distribution, I mean how much is the bandwidth of the LCG, how much is the bandwidth of the LCB, and positive buoyancy. Generally, these vehicles, we allow a slight positive buoyancy in case recovery is made easier. So this positive buoyancy certainly has limits because it has to be counteracted by the control surfaces and the hydrodynamic elements like stern plane rudders. And the input is from a mathematical as well as an experimental models with which we undertake this hydrodynamics. This is an equation which is taken from Fossen, which is mostly used to do the dynamics of the vehicle. In the right-hand side of the equation, what you see as tau will be the propeller and rudder forces. And when it comes to hydrodynamics, AUVs are typically very slow moving, 2 knots to 4 knots, which give a lot of interesting hydrodynamic behavior, which we don't find in other types of vehicles, either ships or even other underwater vehicles, like torpedoes, which are very fast moving, and submarines, which move at a very large size and very different speeds. So because of that, a lot of interesting behavior is there in terms of not just the stern plane reversal, which most naval architects recognize, but also the sufficiency of the stern plane to counteract the positive buoyancy to maintain a certain depth at varying densities if required. Also, we will also be having very interesting behaviors in terms of whether my system is overdamped or underdamped. And the third difference in comparison with other underwater vehicles is that when we see, because of the slow speed, the ratio of the different forces which are going to be balanced, the damping and the restoring matrix in comparison to the propeller forces and the rudder forces, you'll find that the ratios are all very much comparable, in which case the standard neutral buoyancy assumption for stability analysis may not be valid, and we have to do a nonlinear stability analysis, which will also show us a lot of interesting physics and so on. So that is where the AV hydrodynamics becomes very interesting, both from a theoretical point of view as well as from a very practical point of view. Because at the end of the day, before the deployment, when we measure the density at that area, one of the things we have to ensure is that, yes, my vehicle positive buoyancy is not exceeding the limits at that density before deploying, and we may have to have a little rebalance. So both from operation and from theoretical aspects, this is a lot more interesting. Now, when it comes to defining the vehicle, we are using the hydrodynamic coefficients. And one of the interesting things about the hydrodynamic coefficients here is that even though CFD is quite mature to handle these hydrodynamic coefficients, there are a few cases where instead of the purely Reynolds number in turbulence zone, sometimes the AVs may be the speed when we calculate maybe the transition zone. So correctly modeling in CFD is sometimes very problem specific or very vehicle specific. And when it comes to the measurement of the hydrodynamic coefficients, also when it comes to the flatfish shape AVs, we also have to use the horizontal PMM in underwater with proper mechanisms for both the load transfer as well as motion transfer. So we have done this in NSTL, and what you're seeing is a photograph of one of the pure yacht tests that we did for flatfish AVs. And we also did other tests to get the hydrodynamic coefficients, which are put in the mathematical model. When it comes to the AV control, navigation, and guidance, the guidance algorithm defines what should be the path of the AV at a local level. When interlink local level is inside the AV. This path can be defined in 2 ways. One is we can assume, because of the low speed, we can assume the depth and horizontal plane independence. So we can define a depth profile, and we can define XY or the horizontal profile. The horizontal profile can be either defined in terms of the required heading rates and heading, or in terms of lat long if it is a waypoint navigation that we are using. There is also an obstacle avoidance sonar, which will give the input regarding any obstacles which are present. Then we will have obstacle avoidance algorithm, either potential based or A-star or any sophisticated algorithm, to replan the mission to avoid the obstacle and again rejoin the mission path. At the core, we have the control algorithm, which controls the actuation as well as the thrusters for speed control as well as depth control and yaw control. Under the navigation system, we have a set of sensors, the inertial navigation system, which can give all the 6 states as well as velocities, and with some certain protocol, the accelerations also, which can be fed into the control algorithm to know the AUV's state. It is aided by a Doppler velocity log, which helps it to minimize the drift as the time progresses, as well as the DGPS in case the AV surfaces and takes and corrects its position. We can also have a depth sensor to independently give the depth, and an altimeter in case there are missions which require the AV to maintain certain distances from the bottom for effective surveys. Then we also feed the altimeter, which the altitude information also goes to the control algorithm. This is one of the control loop diagrams that we followed, where the trajectory planner was planning the trajectory, then ultimate output was the yaw angle, which goes to the yaw controller, and the yaw controller gives the rudder plane angle. The inertial navigation system feeds in the yaw angle, as we can see. The yaw angle is fed by the inertial navigation system, and the requirement comes from here, and then the yaw controller gives the rudder plane command to the vehicle. Similarly, for the pitch, the depth sensor gives the information, and the depth controller, and the pitch goes from the inertial navigation, and which will give the actuation signal for me for the stern planes. And then if there's a saturate limit, those saturate limits are followed. Then it goes into the vehicle, and the vehicle responds, and again the whole thing is again in the feedback loop. In case of speed, we can also have a thruster controller to control the speed of the vehicle. This is a framework for pitch, depth, and yaw control, which we followed. And we put the whole thing not only in the vehicle, but also in a Simulink model, where the AV dynamics, the control law, the actuator dynamics, and the trajectory planner we put in a framework to study its performance in different environments and different vehicle configurations. Next block, I want to talk a little bit more on the sensors for the AV. One set of sensors we have is the feedback sensors, which is basically the rudder potentiometer. Excuse me. Since the AV is autonomous, it will be having a set of health monitoring sensors, which will be the current sensors, the voltage sensors, and leak sensors. Current sensors, when the vehicle current is some system is taking more current than required. This could typically happen when there's a failure in the actuation or in the failure in the thruster motors. Voltage sensors, when there's a voltage drop typically in the battery, when there is no sufficient battery power. And the leak sensors, which monitor the watertight integrity. In each of these cases, when there's a report of failure, the mission computer systems will be having the interrupts so that it takes a different set of actions to recover the vehicle or give the emergency processes. Then we have the navigation sensors, which is the inertial navigation system. For low-cost systems, we can introduce AHRS, attitude and heading reference units. The inertial navigation systems can be either MEMS-based or when we want more accuracies, it can be fiber optic gyroscope or ring laser gyroscopes. Then we have the Doppler velocity logs. These are basically acoustic sensors which take the sea bottom as the reference and gives the velocity logs, which in complementing the inertial navigation systems, we can design an estimator using Kalman filter to minimize the total error in the system to know the local positions. Next, we have the depth sensor, which gives the depth, altimeter, which gives the distance from the bottom in case that is important for the mission, and the obstacle avoidance sonar. Payload sensors is what the AV is going to carry. The typical payloads are front-looking sonar, which sometimes acts as an obstacle avoidance sonar also. Then we'll be having the side scan sonars, underwater cameras, magnetometers. In case we are more interested in motion observation, CTD meters, sound velocity profilers. The list is quite long. Depends on what we want the AV to do and fit it into the form of the AV. This is the other thing, launch and recovery systems, particularly for larger AVs, this becomes very important. And this entirely depends on whether the mother platform has the capability to handle the AV or it doesn't have the capability and the entire system has to be designed in a self-contained way. In case the mothership has cranes to handle it, we can have an end fitment to the crane and then we can use it for launch and recovery. In case there are compartments which can extend into the sea by opening, then we can have the extract type. Sliding type large are when the mothership doesn't have a crane or doesn't have handling devices. And canopy type is in case the AVs are hosting a lot of sensitive sensors. They have to be carefully handled during the launch and recovery. So depending on the engineering applications, the sophistication and the mothership platforms, we have to engineer these different types of classes for smooth launch and recovery of the vehicle. We have developed in NSTL a flatfish AV. This was designed as a freely flooding and a reconfigurable vehicle where almost 50% of the volume could be freely flooded. It was having an INS, GPS, and DVL aided navigation. underwater and surface communication. In underwater, we used to communicate using acoustic modem. On surface, using UHF. It had normal and emergency recovery aids. The normal recovery aids were GPS locator, wherever the AAV surfaces, it immediately through satellite communication reports the position of the AAV. And the emergency recovery aids was a weight dump mechanism, which in case of leak or in case the AAV for some reason exceeds a set depth, the dump mechanism dumps the weight and the additional positive buoyancy will help the vehicle to come up. Then for mission, we had two modes. One is track following and waypoint navigation. The depth profile was independently defined and it followed the depth profile. And in track following mode, the whole path was defined in terms of the heading and heading changes which were required and the turn rates which were required. And in the waypoint navigation mode, we gave a set of lat longs with a certain miss distance, and the AAV was going through all these lat longs. A typical application, it can have both civilian and military applications. As a survey AAV, one of the possible military missions could be for mine identification by fitment of the payloads, which the concerned payloads. Now, what I have presented is a few photographs of the sea trials, which we did off the coast of Vizag. And we also would thank NIOT because we did a few trials from NIOT ship also. So these are some of the few photographs of the trials. And what I've just now talked is the conventional AAVs. In the past few slides, I've been talking about the conventional AAVs, where we are talking about, based on the experience of the ship design, the screw propeller rudders. The newer technologies, two different technologies which have been looked at, and I know that Dr. Vijayakumar was and is associated with both of them. One was looking at in terms of vehicle gliders, where the gliding principle was used for AAVs by controlling the buoyancy between negative and neutral or near positive. So the vehicle goes and comes down because of changes in buoyancy. No propulsion, no screw propellers. It could have fins to control as an additional control mechanism. These AAVs had very long endurances. They were typically man-portable of weight of less than 40 kgs, but could have very long endurances because the battery power requirement was very less. Only for the computers to control the servo valve for the fins required and the buoyancy engines. Other concepts for the past 20 years, which is emerging, even though the study started slightly earlier than that, was to take inspiration from nature. The next 2 or 3 slides that I'm going to present is mostly from the open literature on the biomimetic AAVs. This is basically because when it came to the vehicles, the AAVs mostly are operating at the sort of length scales similar to fishes or large fishes. And we find that the turn rate of AAVs will typically be in very less, 1 to 5 degrees. While these ships are turning at, these fishes are turning at very high rates. They're able to accelerate very well. And initially the platforms were quite rigid and only using the propulsion. But now more and more research is being done at academic level to see how much you can replicate the fishes. This is from one of the references where all these undulations and oscillations for body and caudal fin motion, both oscillation and undulations, as well as median paired fin propulsion. So all these paired fin or the caudal fin motions, these are all studied on how various ECF motions in terms of either oscillations in the body. As we go along, we can just see that the caudal fin is moving. And here you can see the whole body is basically having undulations. So all these in the initial years, maybe up to say the early 2000s, it was mostly about understanding this swimming behavior. And later, a lot of vehicles have started coming in these lines. And this is some of the concepts as to how to drive the fins in accordance with the requirement of the fin motions inside the vehicle. So these studies have also produced a few vehicles, and we are hoping that with these studies, we can improve the efficiency of smaller AAVs, and it will significantly alter the performance. And the other biomimicry that is done at research level is for the perception itself, where the perception technologies and the sensors which we are designing, typically the sonars, replacing them or enhancing them with the sort of the sensors which a fish has, if I can call them sensors, and using them as the base force sensors. So this is another academic research which is going on. And all these researches are getting combined into certain platforms which are also being done here. So I'm almost coming to the conclusion of my talk, where I just presented a brief on AUV as an underwater robotic vehicle and presented a design framework with hydrodynamic design and vehicle hardware as major groups, with an emphasis on hydrodynamic design, particularly because there is something which you can't change. And just put some thoughts which is available in open literature on biomimetic AUVs, which hope will increase the performance of the AUVs at least at slower speeds. With that, I come to the end of my talk, and now I'm opening up and welcoming the question and answers. Thank you.
Thank you, Bhardwaj.
Yeah.
There are some questions. Okay, the first question from Mr. Kannan PK. Any research activities related to biomimics in autonomous underwater vehicles? Am I audible?
Yes, sir. Yes, sir. Yes, sir. You're audible, sir?
Yeah. The question is, any research activities related to biomimics in autonomous underwater vehicle?
So there is a program which Dr. Vijayakumar is also an active researcher in IIT Madras with IIT Kharagpur and IISc, where a biomimetic AV is being developed. And since it is not my part of the work, I didn't touch upon it. Dr. Vijayakumar, in fact, can talk more about it.
Yeah, there is a research activities being undertaken in combination with IIT Madras, IIT Kharagpur and IISc Bangalore. Joined together, we are trying to develop a fish-like propulsion device, size of about 2 meters in length, and it is that under the funding of NRB, and it is being taken over by Professor Krishna Kutty as the principal investigator. So we like to see at the end of 3 years the matured biomimicking propulsion device, a fish-like propulsion device, and being operated at a small range of certain range and certain length is around 2 meters of that length is being tried out. Okay, that was the one question. The next question is from attendee. Is there any research activities going on to launch the AUVs from the torpedo tubes of submarines?
We have studied the launch hydrodynamics from the torpedo tubes for the axisymmetric vehicles. But specific, yes, we understand the hydrodynamics. There is a significant change because we are talking in terms of purely swim out, because we don't prefer the push out mode. In purely swim out, we have understood that the added masses will be significantly different, and accordingly, we can customize the vehicle for that. So we do have a design for 534 diameter on the standard torpedo diameters. The AUVs of those diameters, with as and when required, can be customized for this application.
Another question. AUVs are going to play an important role in future in terms of research, survey, operations, and also in military roles in many ways. However, considering the large coastlines and large fishing activities in the country, what are to measure being undertaken in AUVs to avoid entangling with the fishing nets and underwater species, stone debris?
So one of the difficulties, I'll just take this question to two different parts. One is the underwater species. When we use an obstacle avoidance sonar or the right sonar, the underwater species is fairly recognizable. So that with a correct underwater obstacle avoidance algorithm is of a lesser challenge to do. And this has also been done with, say, increasing the density, and the simulation studies have been done. What if I increase the density, assuming that I'm able to recognize which is possible with the sonars. Fishing nets present a different challenge because for the range of sonars, they are typically not quickly recognizable. unless the fishing net itself already has a large body of fishes in the trawling mode. But if it's an empty fishing net, it's something which is very difficult to recognize. There is still a challenge to do avoidance of a fishing net. And it's still a research activity. To recognize the fishing net, in case the fishing net is already full, then it is lesser of a problem because sonars are able to recognize it. And then we can do the obstacle avoidance.
This is a question from
Sir, in the meantime, I'm also adding the person who is asking the questions in the panel. So in case if they want to clarify anything, they can do that as well. So we can ask the questioner as the person who is asking the question as well to address that question, if that is fine.
Yeah, you can call Mr. Oral Point. He is there because he's asked two questions.
Yeah, Mr. Pai, you can switch on the video if you want, and you can ask the question directly to the speaker. Yeah.
Yeah, can you hear me, everybody?
Yeah, yes.
Yeah, okay. Thank you very much. I just wanted to know whether we have some international cooperation agreements with other countries with regard to the development of these very high technology, state-of-the-art projects. And what is the indigenous component of some of these prototypes that we are building in our country? Thank you.
So when it comes to indigenous content, as far as the technologies are concerned, except for a few sensor technologies, all the other technologies are something which is indigenous. And the fabrication of the pressure propulsion and the motors are all indigenous, including the battery technologies are all indigenous. Right now, what we are buying from or sourcing from the market is a few sensors. And those sensors also at certain performance levels, we are already available in India. But for an improved performance, we are still sourcing it. But there are programs where the indigenous content will increase in, say, 3 to 4 years, where we are also replacing some of these sensors. As far as the acoustic sensors are concerned, again, they are also completely available indigenous. Now, the navigational sensors at a lower level is available indigenous. Only for the higher level performances, we are still getting the sensors from the market. So that is as far as the indigenous content is concerned. The other thing is the flatfish AV that I presented was basically, you can just say, from the scratch sort of designs where we took a conscious decision to see how much you can do indigenously. And through that project, we have mostly recognized most of the technologies which are associated with the design of the vehicle indigenously. And not only DRDO, we also have a couple of industries which have their own programs in AVs where they're also having almost a similar experience in indigenization.
Yeah, can I just follow up that?
Yes, sir.
Yeah, please.
Yeah. If you look at many of the better developed countries internationally, there is a lot of joint work being done both by the government as well as the private corporate sector, because you require enormous budgets for these type of projects. And there are, of course, the issues of security and so forth. But once we have gone through all that, I think there is tremendous scope in a country like us. It was so nice to see about what the Tata Group is doing with regard to manufacture of aircraft for the Indian Navy. And I think there's a lot of scope also in other areas like ocean engineering, where both the corporate sector and the government can work together, provided the secrecy and strategic issues are well taken care of. Thank you.
Yeah, I accept your point. In our AV programs also, there are, as I told, at one level, which could be a dual-use commercial and military applications. The corporate sector has also done a few AVs. For example, I didn't present the national scenario, perhaps it would have been more appropriate. There are, say, for example, L&T has produced its own AV with its design, which has been tested. CMARI has also produced its own AV. NIOT has produced a very small AV, which has been highly popular, highly published. And then NSTL, whose missions, because we are in the military sector also, where NSTL has produced the design. So there is a minimum understanding about what these entitle. And between the corporate and the government, there's a lot of sharing which is happening using different channels. where eventually it is being produced by the corporate, even for projects which are otherwise on and not on in the public.
Yeah, thank you. I think that's really the way forward. There has to be a sort of national cooperation arrangement between the corporate sector as well as the government. Thank you.
Thank you. Next is Captain Amit Ray. Haridhar, you can come online.
Good evening, sir. Am I audible?
Yeah.
Yes.
Good evening, Bhardwaj. Dr. Bhardwaj has
Yeah.
given us a really excellent presentation, and the level of detail of every aspect which he has covered is indicative of how many years he has spent in this area and taken to maturity a lot of concepts. So for Bhardwaj, I've got two small questions. One is, will it not be better to go for a neutrally buoyant AUV design so that one can conserve energy as well as make the hydrodynamics simpler, so that we need not give undue importance to the necessity to surface in an emergency?
A neutrally buoyant AV is always ideally we would like the buoyancy to be as less as possible, so that we don't have to give undue importance to the buoyancy. That's a given. Unless there's an operational requirement for me to have a positively buoyant vehicle, neutrally buoyant vehicle from hydrodynamics point of view is always advisable. But there are certain operational situations where I have to account for the buoyancy, at least to check things. For example, there could be density variation in case of AVs which go on a long missions or over a period of time. So I have to account for the density variations and just ensure that because of density variations, if there's a change in the buoyancy, my AV has the capability to handle it. There are two ways to handle it. One way is either I have a buoyancy engine which controls the buoyancy so that I always have the neutrally buoyant in any case, or have these control surfaces to counter for the buoyancy. Either can be done, but ideally, yes, neutral buoyancy is the ideal thing to achieve. But yes, for losses, a slight positive buoyancy is sufficient. The buoyancy need not be great. I would say less than 1% of the buoyancy could be good enough. But in case, and again, in terms of absolute values, if we see for very large AVs, maybe 5 to 7 kgs should be good enough, unless it is a very small vehicle where you have to go in terms of grams.
Right. Thank you so much. The second small point was which of the main components that you have identified or the subsystems of the AUV, which component system would you consider most challenging in development? Like is it the vehicle hydrodynamics or the navigation or so on?
Generally, the bias is towards the things that you don't know. In that sense, I'll tell that one of the difficult concepts, probably because we are also, a lot of people are finding it very challenging in the country, is about the localization. There is the navigation sensors which help to tell me where my vehicle is. Because hydrodynamics is something that probably I have a bias of knowing hydrodynamics, so I'm just telling this. But as time progresses and the AV is underwater, the navigation sensors are going to drift and there's a correction which is required. So every time there is a need for the surfacing, or I have to improve the performance of the navigation sensors. And this is proving quite challenging in the overall scenario. Of course, there are other technologies that are important like batteries so that I can minimize the vehicle size or increase the endurance, or those things are there. But navigation is something which I'm finding it as somewhat challenging.
Right. Thank you so much. And taking your response to the previous questioner further, we would be reaching out to various institutions seeking assistance in development of AUVs and the technologies.
Yeah.
Thank you so much.
Thank you. Thank you.
Amit is currently in Navy, Captain Amit Ray, so he's speaking from that perspective. And since Amit has asked few questions, I will also add. Can I ask? Huh?
Yes, sir. Yes.
Yeah, yes. Okay. This flatfish AUVs are not that popular, no? What was the motivation which is made you to go for flatfish AUVs? Because I have not seen many flatfish AUVs.
Yes, if you see the flatfish AUVs, if you see there's Bayamba in Australia, the Marius AUV, and one in South Korea. And yes,
very few.
there are very few. I mean, you can count it with 2 hands. One of the reasons was that it's to start with an inquisitiveness, because axisymmetric AUVs, when we started, we fairly understood the hydrodynamics of these axisymmetric ships because of the other platforms that we were doing, and we were able to simulate. It's a matter of engineering only, but as a hydrodynamic understanding, we had a clear understanding. But we also wanted to know, what is this flatfish AUV? Why some people are looking at it? Is there a difference between the nature of the hydrodynamics of the flatfish AUV vis-a-vis the axisymmetric AUV, and where it is having an advantage, where it is not having an advantage? This is something that we wanted to see. So as more like a technology demonstrator, we took up that. And particularly what we found out was that when it comes to the stability, both in terms of hydrodynamic stability, when we calculate the hydrodynamic stability coefficients, yes, both are stable vehicles, axisymmetric and flatfish. What happens is that in the case of flatfish, it's a bit more stable, and it's very hard to compare the equivalent vehicles, because again, then we'll be going into what is the correct way of comparisons. But in the very broad sense, if you can tell, the flatfish AUV is little bit less stable as a number in the horizontal plane and a little bit more stable in the vertical plane. Again, it's the numbers which characterize how these are.
It will have an effect on its maneuver.
We have a very stable run for maybe a certain time to carry a certain set of sensors. Where I require a very stable depth platform, I would rather go for a flatfish AUV. Otherwise, I have to do, say, add certain fins or certain elements to an axisymmetric AUV to achieve a similar performance.
Okay. Some more questions. Anonymous attendee. Does NSTL uses MSS toolbox developed by Fosen in Simulink models for simulating AUV motions?
No, we did take Fosen model. This was also the Simulink model that I showed was also developed in collaboration with the IIT Madras Engineering Design Department. We didn't use Fosen's toolbox. We only used Fosen's equations, where a few terms we have just customized according to our requirements, particularly the propeller model, because the propeller model and the rudder model is something that we have changed in accordance with the way we measure the hydrodynamic coefficients. The broad concept was taken from Fosen, and accordingly the model was written. The model that I showed was also in collaboration with the IIT Madras. Professor Ashokan of IIT Madras was instrumental in writing that model. Yes, Fosen toolbox we didn't use, but the Fosen model, the broad mathematics of the Fosen model was used in the NSTL model. And also NSTL has got one more model which we also check. The Feldman model also is independently written. The Feldman model based 6-DOF model is also there with NSTL. So whenever we do these designs, we compare the results with both the models.
Okay. The next question. For a flatfish AUV, was USBL or LBL used for positioning? If not, what was the INS drift with respect to time? Say for 10 minutes. Yeah. Yeah. Please, sir.
Yes.
You can ask yourself the question.
Yes, sir.
Come on.
Good evening, sir. So, for the flatfish AUV, was any acoustic positioning methods used for positioning?
I used an USBL for tracking, not for positioning, but I used an USBL link for tracking the AUV within the range of the USBL signals. But for the actual positioning, I was using the FINS INS, which had a pure inertial mode of 0.6 nautical miles per hour. And with DVL assistance, it was 0.01 second lat. Degree per hour second lat. This was the class of INS that I was using in the vehicle for its position. Independently, I was using an USBL tracking system to track the vehicle.
I see. So, does INS drift affect how you plan trajectory for your AUV? Because your position is not absolutely certain when it's deployed.
When it's deployed, it is taking the GPS input, so we are certain of the position. But in case you're doing a long mission for, say, that particular AUV, flatfish AUV, was for the maximum endurance of around 7 to 8 hours. So the need for surfacing was very less within the INS errors. But if you are going to have a longer mission, then there is a need for occasional surfacing. If you're doing a volumetric survey, it will not matter much, particularly if the depths are low. But if you're doing an area survey at slightly deeper depths, then it could only make the what you call as the effective mission time in terms of the survey date versus the total mission time little different. So, for example, you may be surveying and then you have to occasionally come up and go down. These ascent and descent times are also the mission time, which is not effective for your mission. So, in that sense, there is a difference between different INS performances. Otherwise, so this is some accounted for during the path planning before you plan the path.
I see. Thank you very much. This was very.
Yeah. Next is Shashank.
Sir, already the questions which I asked have been answered. So thank you very much.
You asked one more question also.
I was actually looking at the details from NIOT also on the components which they are developing or they have identified to be indigenously developed for their ROVs, along with the components being developed by NSTL.
Yeah, actually, a lot of the ROV and the manned submersible which we are making right now, a lot of them are like bought out and imported only. And this is the first one, especially for the manned submersible. So it's more like putting things together. But basically, the titanium hull, which is the most important part of the manned submersible, that actually, though we are going to buy one also from abroad, we don't really have the capability of welding such a thick titanium hull. And so that work has been also given to ISRO so that they can develop a system and make it, develop that infrastructure to make that. And they are also going to make a hull parallelly in ISRO so that, slowly we will move towards complete indigenization. And I hope that answers your question.
Yes, ma'am. Thank you very much.
I would also add something more.
Sir.
When it comes to some of the technologies, for example, the thrusters that we used, whatever thrusters were used, the 5 kilowatt thrusters which were used by NIOT in their ROVs, some of the things were very much in common with the AAV. What I mean to say is that in underwater thrusters, sonars, there will be a lot of commonalities which can be put either in an ROV platform or in an AAV platform and we can customize. So that way there will be a lot of commonalities, not necessarily with NIOT, but even with some of the technologies of ROV as well as AAV when it comes to sonars, thrusters, probably the INS also, if you want to localize local positioning of the ROV or the AAV. So some of the sensors will be common, thrusters could be common. So there could be commonalities between ROVs and AAVs in that sense.
Okay, sir. Thank you.
Yeah. There are some questions from Mr. Krishna Prasad. Are the subsystems used in AAVs are indigenously developed? That is answered to most of the things and some of the things about. What is the best type of LARs for the 10 meters AAV? LARs for the 10 meters AAV?
I would say that if in case the platform is the mothership platform can accommodate in terms of its height from the sea level, then a sliding type ROV, sliding type launcher is very good because it is for lesser complexities in terms of crane and every handling. But that also assumes that the deck from which I launch is having a low height from the sea level. But if in case there are higher heights, then it is something which is very difficult.
The next question is from Dr. Ghosh. Roy, is he available?
I think Dr. Ghosh was also not in the call. So I think, sir, you can take the questions.
Yeah, you have opened up an old view of concepts. Is it not possible to start experimenting with a few concepts and make it a success? They have already done it. NSTL have done it.
So can I have a question? So it was, I'm not sure it's a comment or a question. Yeah.
You have opened up a whole world of concepts. Is it not possible to start experimenting with a few concepts and make it a success of it?
Basically, that's what all these. I presented a little less on the flatfish AAV. The actual experiments which had gone to the trials, we put all these concepts into one AV, and we did the sea trials of the flatfish AV to see that these concepts can be integrated into the vehicle. Now, there are other programs where we are doing for better performance and endurance.
Next question. One of the greatest challenge of AUVs are endurance and long-range missions. Is there any research going on for a ways of improving endurance of AUVs?
When it comes to endurance of AUVs, there are two spectrums. One spectrum is have a large size AUV, which means you are putting more batteries, and of course the stability is governed by the LVD ratios. That is one end of the spectrum where you have very heavy AUVs for very long endurance. The other spectrum is the gliders, which is at the other end of the extreme, other end of the weight spectrum, where it is man portable. The operation is by a small buoyancy engine. As Captain Amitri was telling, we are operating at neutral buoyancy, just the negative buoyancy, very less negative buoyancy to make the AV glide. And since the power requirement is only the computer system and maybe a fin and solenoid valve, the power requirements are very less, and these typically operate for months as reported in literature. So these are two extremes for long endurance, and both the things are attempted for different missions.
So, can you throw some light on the latest work on the batteries, lightweight batteries?
Beg your pardon, sir? I just go across. I know who the question is from. I just go across.
It also vanished from my screen.
Yeah.
Okay.
No, what is lightweight batteries?
I think Bakshi sir is asking.
Yeah, that's what I just told. Otherwise, I'll just go across and just get the question. But was it on the AV or was it on batteries that he was asking?
This was on the lightweight batteries.
Lightweight batteries. Mostly, increasingly, we are moving to sodium and lithium air batteries. That is one concept which is a lot of research is happening. In sodium-based chemistry instead of lithium-based chemistry, sodium-based chemistries, aluminum oxide batteries, and lithium-air batteries. These are the key concepts. There are a lot of research is happening. At laboratory scale, there have been some work done, but with respect to aluminum, scaling is a problem. Scaling, I mean, not the battery itself, but even the manufacturing scaling is a problem, which is trying to, people are trying to address that. Lithium air and lithium air batteries are again coming up in terms of electrodes, in terms of electrolytes. A lot of research is happening. The other thing is the sodium chemistry itself to kill the dependence on this thing. So these are some of the things which are coming up. Other than the standard, what we read regarding lithium polymer or lithium ion batteries, which are mostly established.
Next question.
And fuel cells, just to add, fuel cells is another option. There also research is happening. Instead of batteries, we'll just go to fuel cells. And we can get long endurance from fuels. That is other end which is happening.
Mr. Tony KP, is he available? So his question is on what are the research challenges associated with AEV control?
One thing is AEV offers an interesting possibility that you don't have to do PID control alone. We can go for the nonlinear control modes, not necessarily PID. Sliding mode and all these controls can be tried very effectively in the AEV. But getting a stable vehicle from the point of view of control, as I was telling, because it is low speed, and as once you define the vehicle configuration, it is entirely possible that depending on the speed, the vehicle could be either overdamped or underdamped, because of which the controls could be different. So this also has to be studied properly, whether I'm designing it for an overdamped system or an underdamped system. Sometimes whether I have to define a trajectory at each time instant or whether I can directly go for the required trajectory in terms of control stability. But most of these works are done. Only when it is coupled to navigation, then we have challenges. And the second challenge is the configuration of the number of control elements itself. For example, how many control elements, when you increase the number of control elements, the challenges of managing all in an optimized way is the next challenge.
Yeah, we will have the last question. I think this also time up. This question is from Mr. Surya Narayana. Is he available?
Yeah. Yeah. Good evening, everyone. Dr. Bhardwaj, congratulations. And this is IMU Director.
Good evening, sir. You have
Good
always
evening,
been
sir.
very regular in NSTL.
Kochi campus. Nice to see you. And
Yes, sir, nice,
Madam Purnima also, I thank her very much for giving an overall overview of the blue technology and initiatives by the government. It will be of help for many people. And Bhardwaj, can you please indicate what are the areas the industry and the academia need to focus in future?
Yes,
with your technology forecast from defense perspective or from the civilian applications point of view?
Sir, we are still focusing when it comes to the academic. Still, there are some challenges in the entire propulsor design itself, which I know you have been guiding us when you are in NSTL. Those open challenges are still to be completed. One way we are doing it is in the biomimetic, where we can improve the propulsion. Propulsion technologies are also being tried.
Okay.
This is one area of academic research, sir. The other area is the vehicle shape optimization itself, particularly when it comes to, say, whether I can have riblets and how these riblets perform, drag reduction technologies, either by coatings or by ventilation. Drag reduction technologies are another area which we are hoping the academicians can come in and contribute a lot. When it comes to launch and recovery, we think it could be an industrial problem, which could be a well-defined problem for the industry to handle and the operational level people to handle when it comes to launch and recovery. And then the other academic topics are in navigation itself. As I was telling to Captain Amit, the navigation technologies is a challenge. There are two challenges in navigation technology. One challenge is, given a set of sensors, how effectively can I have a design an estimated probably Kalman filter based to improve the performance of a given set of sensors? That is challenge number one. Challenge number two is in the sensors itself, where I can have improved sensors. These are all the various challenges or research areas that I can
if you can bring out the future requirements to be participated by Indian industry and the academia, and present in this type of forums, I think probably it will be of help for the academia and industry to look into. That's what I want to suggest.
Yes.
Sure. Thank you.
Thank you, sir.
Thank you, sir.
So we are coming to the end of the session, and last part is to summarize the lectures given by Dr. Purnima Jalihal and Dr. V. Bhardwaj. So it is my honor to summarize the work. Coming to the Dr. Purnima Jalihal's talk. Thank you very much, madam, for bringing out a presentation to showcase the amount of work which is being done at NIOT. And of course, this is not quite comprehensive and elaborate and all the topic which you have covered. It is still lot more you are doing it, which I also know personally. And that also it has been brought out in the some sessions of INA lectures. It would have been very fine, madam. And that talk specifically on the blue water economy and the framework, talking about the energy and the underwater technology, touching on the SDG 14 and the important one of the life below the water. If not the life originated from the water, now looking life below the water, and also touching upon the 7 priority area which you have identified. Of course, all the priority area, we are still in the stepping stone. Coming to the priority area number 3, where we were the pioneers in the fishing of fishings and ocean fishings. Now we have reduced a lot into the fishing industry in oceans. Of course, in the inland fishing is increased a lot, whereas in the ocean fishing there is a diminishing fishing activities compared to what it used to happen, percentage-wise increase which has happened in the inland fisheries. Then your contribution in setting up the first ever ocean thermal based desalination plant in Kavarathi is quite winning, economically winning. In fact, for every island to get into this, getting the fresh water and solving the freshwater problem is very remarkable, and the highlighting those presentations in the presentation is also very good, madam. I'd like to thank you on behalf of the INA for delivering such a wonderful lecture. Coming to Bhardwaj, the work which has been done, which in fact he has been working on this for the last 16-20 years on these in the AUVs. He has brought out almost like how to design a glider, or almost all the aspects from the technology, AUV development process, then the AUV sensors, launch and recovery, almost all the topic has been covered. We would have been more happy if yes, given some more light into the practice, this one experimentation which he has done, or trials which he has done, but of course he got certain limitation in giving that, and even comparing the aerodynamic coefficients for accessibility body and this typical body, and then highlighting those things would have been much better. Anyhow, a very nice presentation from Bhardwaj, and the work which has been done has been presented very well. Thank you very much. And the session itself was very pleasant, and it is on the topic of interest of mine also. I am also working on the gliders for quite some time, and I'd like to thank INA for inviting me as the chair, and also thank both the speakers for giving a wonderful lecture. Thank you, sir.
Yeah.
Thank you. Can I just make a couple of just comments? It was really a really wonderful presentation, and a topic which fascinated me all my life, especially the motion of the stingray, how it maneuvers close to the surface. It was always fascinating. And the discussion on the flatfish possibly, and simulation of the motion of the flatfish, if that has been understood and analyzed, it's a well taken direction. It's very interesting actually. We are very happy to have Professor Surya Narayanan here today, the director of IMU. Thank you very much, sir, for attending our.
Thank you, sir. Thank you.
Thank you very much. If Dr. Jalihal, would you like to have any closing comments from your end?
No, it was a very nice, informative session by Dr. Ayyangar, and all I can say is thank you very much for letting me be here and speak a few words. Thank you so much.
Madam, thank you also.
Anytime. And thank you very much, Dr. Ayyangar.
Thank you, sir.
It was an excellent presentation. Really enjoyed it. May I request Commander Kaple or Amir to give the vote of thanks?
Sure, sir. Thank you very much. So indeed, it was a very great session today. So firstly, on behalf of INA, I would like to thank you all who have participated in this webinar. And the participation has been very active. We had more than 170 registrations till today morning, and out of that, more than 80 attendees had joined us live on Zoom and YouTube.
Nice.
So this has been a very active presentation. And special thanks to all the senior members like Captain Mohan Ram, Dr. Ghosh Roy, as well as others to make this webinar a great success. So this success has been due to the excellent presentation made by Dr. V.B.S. Ayyangar. Thank you, sir, for sharing with us all the current developments being undertaken in the autonomous underwater vehicle. We are very grateful to you. Me personally, having some background in ROV and AUV analysis, I can definitely say that this was an enriching session for all of us. Thanks to our chief guest, Dr. Purnima Jalihal, who spent her busiest time gracing the occasion and sharing her thoughts on the topic as well. And the excellent way it was being conducted and chaired by Dr. Vijayakumar. We are all privileged to have you all here today. Thank you. Finally, I thank my colleague on the INA Executive Committee, including Ms. Helvi, Mr. Sujit Bakshi, and Mr. Kaple for their initiatives and efforts put forth for the smooth conduct of the webinar. Thank you very much. Before we conclude, I would like to bring you notice that INA intends to conduct these webinars every month to showcase more on case studies, new technologies, innovations, development, etc. in the maritime industry. So we request your active participation in the upcoming session, as well as any suggestions related to improvement in the session. The specific topics you may like to include can also be communicated to the executive committee. So I once again thank you all for your active participation. Have a great day. Thank you very much.
Thank you very much.
Thank you.
Thank you.
Bye.